Spectacular time-lapse photography from the west coast of Greenland. 75 minutes of still pictures, taken just one frame at a time, and then sped up to show a chunk of glacier the size of a mountain plunging into the sea. It's a stunning example of what photographer James Baylog has made his life's work. Wow!
Look at that. That's the height of El Capitan, the big cliff in Yosemite right there. Yeah, it's just turning up out of the ocean.
Wow. For nearly 30 years, Baylog has been a nature photographer, capturing the world in still life glory. But now, Baylog is out to document the Earth as it changes right before his own lens, and his latest project tells an alarming tale. In 2006, Baylog founded the Extreme Ice Survey, a project to show what global warming is doing to glaciers. He and his team placed 27 still cameras in 18 locations on glaciers all over the world. Month after month, the cameras snap a picture anywhere from once every half hour to once a day, recording a process that would otherwise be impossible to visualize.
What we're doing here is bringing alive the process of the changing climate and the impacts on a place. This is really an indicator species. It's just like a canary in the global coal mine, you know? It's the place where you can see the impacts of climate change come alive. And in that sense, that's really what I'm after here. I'm trying to animate and make real climate change. It's not about statistics, it's not about computer models. Like everybody else, I thought the glaciers changed fairly slowly. They were at a glacial pace. This stuff doesn't change slowly in the current environment we have. It's changing really quickly. This is the Ilulissat Glacier. It's on the central coast of western Greenland. It's about halfway north to south, and it's the single biggest discharge source of ice from the center of the Greenland ice sheet out into the ocean.
Wow. So one of the biggest into the world, really, into the global ocean.
Well, compared to Antarctica, Greenland is still small, so I wouldn't go that far. But it's a major creator of icebergs and global sea level rise.
All right. And how big is it? I mean, in terms of side to side, maybe?
Well, left to right, the calving face is about 4.5 miles across.
Wow.
And the walls of ice on it are typically 300 feet high. Sometimes in odd circumstances, they go up to maybe 400, 450 feet. But one of the things that's so incredible about it is there's so much ice coming off it that in front of the calving face, the ice is packed so densely you could walk across the ocean and never touch the water. It's just a massive,
a pile of ice that's on top of the water.
Congestion of icebergs.
Wow.
And in fact, we've been down there with the helicopter to measure how far above sea level that pile of ice is, and it's well over 100 feet above sea level out in front of the calving face. It's just this great big, almost a talus slope, a wedge of ice that falls off the calving face before it actually works its way down to sea level. This glacier is moving 125 feet a day, which is really, really fast. The belief has always been that the iceberg that sank the Titanic came from this glacier.
From this glacier?
Yeah. And by the ocean movements and the statistics of ice discharge in western Greenland, there's a good chance that was actually true.
And each frame, how far apart is each frame taken?
Every hour or every half hour in this sequence.
Okay.
Yeah.
All right, because it looks just like a roaring river. I mean,
it's it doesn't move that fast. It's all sped up time, but yeah, it's a river of ice for sure, and it's this tremendous conveyor belt putting all this stuff from the massive inland ice of Greenland out to sea. You know, this is how you move it. Get rid of it.
This is over a 3-year period, this sequence we're watching.
That's just about 3 years on the dot.
Okay. From June to June.
Yep.
And over that time period, aside from just the astonishing sort of daily flow, what did you learn about this particular glacier?
Well, it looks like the calving face is continuing to retreat towards the interior.
I see.
Okay. This has been in a rapid retreat since 2001. Backing up a little further, the glacier was staying stable up to about 1880, way out at the end of the fjord. And it slowly, in pulses, went forward, backward, but net backwards over about 100 years. And then it started to speed up. And then in 2001, it went into a very fast retreat period. It lost a huge amount of ice between 2001 and now. And it's slowed down a bit the past few years, but it's still chiseling its way back into a spot here, just outside the right edge of this picture, where it could get very unstable and go into what we call free fall, the same way some of the Alaskan glaciers have been.
And so the thought is that a huge sheet of it may just break off once it doesn't have enough support.
Yeah, oh yeah, and you
that.
should see what's happened in these same kinds of glaciers in Alaska when that process happens. It just goes with incredible speed when now it's just a tongue of ice sitting up on top of the water flapping around. To me, these things are shocking. You know, this is not the way you think the world is supposed to behave. And it's certainly when we started the project, I consulted with people who had been working in this field of glaciology for far longer than I ever have been. These are the real international experts in this field. And none of us imagined that these cameras would see this kind of change in this period of time. Absolutely astonishing. What happens is that on just a daily basis, when it gets warmer, you see the glacier speed up. So warm days it speeds up, cooler days it slows down.
Wow.
And it's cycling that quickly. So if you have a warm spring that comes early, you put more ice in the ocean. You have a hot summer, you put more ice in the ocean. It's happening like that. The human race is kind of jumping into the middle of Earth history here and trying to understand what's happening, but certainly based on the trends we see from the instrumental record combined with the field geology where the story is left in the rocks. There's a lot of evidence laying on the ground out there if you know how to look at it. Between those two things, the field geology and the instrumental record, the satellite record, you can put together a reasonably accurate and well understood picture of what's happening in Greenland. And the story is, for sure, that we're losing lots of ice in Greenland.
Balog explained how the blue and purple areas on this map of Greenland show where the ice cap is melting the fastest. The brightest areas are in the southeast. I asked him about the recent expedition I joined to Greenland with the Coast Guard, searching for a missing plane, a plane that crashed during World War II with 3 heroes on board. We didn't find the plane, but one of the biggest questions we had was, is it even still there? Has the glacier in which it's supposedly encased already dropped it into the sea? So southeastern Greenland, where we are looking for our plane, is all this purple and blue fringe. What does that mean?
Well, that means ice loss.
Ice loss.
Yes, and that's a place where a relatively large amount of ice is disappearing. That area where the plane is one of the areas of maximum deflation of the ice sheet. Who knows where that airplane is, given the amount of flow of that ice and the retreat of the ice down there.
So it may be the worst hopes of the Coast Guard team that we were with have long been confirmed, and that is that the plane has moved out to sea or been dropped into the fjord.
It's conceivable. You know, I don't really know what the flow rates are down there, but flow rates in the realm of 25 to 100 feet a day are not at all out of the question, depending on where it is in the topography of the underlying bedrock. So, you know, who knows? It could be trapped in a little pocket and it could be steady, or it could be miles gone at this point.
I see. Balog's cameras are still clicking away, recording the rapid retreat of glaciers that have existed for thousands of years.
I've been climbing on glaciers and mountains all around the world for 40 years, and I've been in this field of natural science to some extent for, you know, off and on for that 40 years. And nothing I've ever done had prepared me for imagining that big monumental landscape features like that were going to change to that degree in this period of time.